Right, next we're going to talk about circular motion. So what happened if like something move in a circular? So suppose a point moves along a circle as shown in the figure. So there are two ways to describe the motion: linear speed and also angular speed. So these are going to be the two terms that we are going to discuss, so which is the linear speed and also angular speed. So what is linear speed and angular speed? So this is going to be the full, what do you call that, the full definition of them. So linear speed is the rate at which the distance traveled is changing. So when we talk about rate, so we are actually talking about time. Anything that is related to rate is always going to be over time. And for this case, what is going to be over time? So it's basically it's mentioned over here. So linear speed is actually the distance traveled, so divided by the time elapsed. So that is going to be linear speed. And what happens is that linear speed is denoted by the notation mu. Okay, and then we also have the angular speed. So angular speed is the rate again, so it's related to time because it's rate at which the central angle is changing. So angular speed is basically the number of radians. So basically it's going to be the theta, the angle, how the angle changes divided by the time elapsed. So the idea is that it's going to be the angle, so divided by the time. So that is going to be in terms of angular speed. And angular speed is represented by the notation omega. So this is not W, so this is actually omega. So put over here, so it's called as omega. Alright, and again, so if there are specific formula for linear speed and angular speed, and in order to use this, what you have to do is you have to make sure that your angle is going to be in terms of radian. And of course, in terms of linear speed, it is related to something that we have seen before, because when it says about the distance travel, so the distance is going to be talking about the arc length. So arc length is something that we have seen before. So we are going to apply whatever that we have seen in the previous video. So it's going to be distance, and this distance is actually represented by arc length. Okay, so this is going to be the formula. So angular speed is going to be theta over t, so the angle changes over time, and the linear speed nu is going to equal s over t. So it's going to be the distance traveled, so divide by t. And we know that from what we have discussed before, so there's a formula for s, and s is given by r theta. So basically it's going to be s is going to equal r theta, s over t is going to equal r theta over t. So that is going to be the angular and also linear speed. Okay, so example number 1. So here a boy rotates a stone in a 3-foot sling. So sling is like, so this thing over here, so it's called as being a sling. So slingshot, it's called, what is slingshot in Bahasa Melayu, by the way? So it's the idea of like attaching something to a not to a rope, but yeah, attaching something with a long handle. So a boy rotates a stone in a 3-foot long sling at the rate of 15 revolutions every 10 seconds. So find the angular and linear velocities of the stone. Okay, what information do we have here? So it says the boy rotates a stone in a 3-foot long sling. So what happened is that this 3-foot long sling actually represent the radius. So this is going to be the center. So here the radius is going to be 3 feet long. So that is going to be the unit, it's 3 feet. And it says that at the rate of 15 revolution every 10 seconds. What does 15 revolutions mean? So revolution actually means one complete circle. One complete circle. So actually in this story, so this boy actually rotates 15 revolution. He makes 15 complete circle, so every 10 seconds. So that is actually pretty fast. I'm not sure whether this is correct or not. Okay, but the idea is that in 10 seconds he can make 15 complete rotation. I think that makes sense. So it's going to be like very quickly. Okay, so that is going to be the information that we have. And from that information, so we're going to find the angular and the linear velocity. And I would like to remind you, so the fact that, remember, so what happened when we have one revolution? So when we have a complete circle, so what happened is that the angle, So let's say if I were to start here, okay, so if I were to start here and end at the same point, so that is called as being one complete circle. And the angle of one complete circle, so the circle in here, so that is going to be 360 degree, so which is equivalent to 2 pi radian. So that is going to be in term of angle. And what is going to be in term of the arc length? So if I move like one complete circle, so what is going to be the S value? So the S value is going to equal, remember the formula? So let me put somewhere on the side. So the formula for S is equal arc theta. So for one complete circle, what is going to be our S? So it's going to be R multiplied by theta, which is going to equal 2 pi. So basically for one complete cycle, so S is going to equal 2 pi R. So let me put over here for one cycle. It's not one complete cycle, it's one complete circle. This is not ODE, this is technical maths, okay? So whenever you come across like one complete circle, so we know that the arc length for one complete circle is going to equal 2 pi R. Okay, so based from the information, so first we are going to find the angular velocity. So angular velocity is given by omega, and according to what we have seen before, so omega, the formula is going to equal theta over t. Okay, what is going to be the theta for this case? So let me put over here. So one revolution, what is going to be the angle of one revolution? So that is going to equal 2 pi. But for this case, so the boy had 15 revolutions. So therefore, so when we have 15 revolution, so what is going to be the angle? So that is going to be 15 multiplied by 2 pi. So that is going to equal 30 pi. So the when he what do you call that, swings that around, so it actually rotate to an angle of 30 pi. So that is actually a very big number. So that is why we can substitute right here. So what is going to be the theta value? So that is going to equal 30 pi. And for how long? What is going to be the time for that happened? Like the 15 revolution take how long? So it is going to be every 10 seconds. So time is going to be in 10 seconds. So therefore, when I simplify this, so I will end up with 3 over 1, which is 3. So my angular velocity is going to equal 3 pi. Okay, so what is going to be the unit of this? So if you remember, theta is going to be in term of radian unit. So t is going to be in term of second. So that's why this is going to be 3 pi radian per second. So that is going to be the unit for velocity for this case. Sorry, the unit for the angular velocity. And aside from angular velocity, so we are also interested with the what do you call it, the linear velocity. So the linear velocity is given by nu. So that is going to be given by s over t. So the distance divided by time. And it's going to be the same idea. So one revolution, so the distance traveled for one complete circle is going to be 2 pi r for one complete circle. But we have 15 revolution for this case. So that is going to equal 15 multiplied by 2 pi r. So which is going to equal 30 pi r. Okay, so for this case, it's going to equal 30 pi r over 10 because the time is 10 seconds. But of course, we have to substitute what is going to be the value of r. And for this case, we know that the value of r, so that is going to equal 3 feet. Okay, so now we're going to substitute the fact that this is going to equal 3. So I'll end up with 30 pi multiplied by 3 over 10. So when I simplify, I will end up with 9 pi. Okay, so what is going to be the unit? So s over here. So what unit is it going to be? So it doesn't say over here unit of s, so it doesn't matter. So no need to mention that if it's not mentioned. So simply going to be 9 of pi over seconds. So that is going to be the distance. But yeah, it says over here. So r is going to be in terms of feet. So therefore, this is actually 9 pi, so feet per second. So that will be the distance travel or the linear velocity. Okay, just the same, it's just with explanation. So as what I've shown you before, so the angular is going to equal 3 pi and this is going to equal 9t. 3 multiplied by r, the distance traveled. Okay, and then we're going to have a look at the relationship between linear and angular speed. So previously we have seen that. So for the case of the linear speed, which is new, the formula is going to equal s over t. And for this case of angular speed, the formula is given by, sorry, it should be not omega here. So angular velocity is represented by omega. So omega is going to equal theta over t. Okay, as what we have seen before, we know that what is s, and s is actually given by r theta. So that is the formula to find the arc length. Multiply the radius and the angle. And we know as well that theta over t, so that is going to form the omega. So that's how we can derive this formula right here. So the fact that actually the linear velocity is going to equal r multiplied by the angular velocity. So meaning that if you know the value of one of this, okay, so you can actually just use this formula, nu is equal r omega, and find what is going to be the other value that is missing. Meaning that if you already know linear, you can find the angular, and if you know already the value of angular, you can find the value of the linear velocity. Okay, so this is going to be the last example. A woman is riding a bicycle whose wheels are 26 inches in diameter. So now we're talking about wheels of a bicycle. So let's say this is the wheel of the bicycle. Okay, I'm really bad at drawing, so please don't mind me. So here the diameter is given by a value of 26 inches. So we know that diameter is actually twice the radius. So therefore for this case the radius is going to equal 13 inches. So if the wheels rotate at 125 revolutions per minute, so it rotates in 1 minute, it actually rotates how many times? 125 times. So it says find the speed at which she is traveling. Okay, so for this case, what happened is that we wanted to find the speed, which is going to be the linear velocity. So actually for this case, so you can find the linear velocity right away. So instead of like having to find the angular speed and then convert it to this to the linear velocity. Okay, but this is just an example, like how they are actually related. So if I find the angular velocity of the bicycle, so I know that the angular velocity is going to equal 2 pi. So that is going to be multiplied by 125 rotations. So I'm going to have 2 pi multiplied by 125. And the time is going to be in terms of unit. For this case, it's going to be 1 unit. So I will get that. So my angular velocity is 250 pi radian per minute. And then using the formula that we have before, so the fact that nu is equal r multiplied by omega. So knowing that the radius is going to be 13, so I simply multiply by the omega, the angular velocity. So I will get a value of 10,210.2 inch per minute. Okay, so it makes sense because the bicycle goes like very fast. You couldn't even see the wheel turning. Okay, right, so if you have your value of nu or omega already, so no need to bother like doing the same calculation again for the other one. Just simply use the formula. So I have, as usual, a bunch of exercises that I want you to try. I know that this is not going to be easy having to read these things, but try to read them, extract the information, and then decide so what the question asks and what formula should you be using. And of course, the solution is here as well. So